So this paper, the fundamental of data science, the paper number is PBD 2801. It's basically for programming for big data. So there were a 6 unit is in this paper. The first one is a graph theory. Second one is a high dimensional spaces. Third one is a random graph. The fourth one is singular value decomposition. In short, it's also known as SVD. The fifth one is the random walk. And sixth one, which is the algorithm for massive data. So as this course is divided into this main topics, let us give the introduction to each of this and some of the motivation to study this paper. So the first topic which we have here, it is a graph theory. And in that graph theory, the basic concept of what is a graph. When I say it is a graph, it is not like x-axis and y-axis. So this is not the definition of the graph. A graph is made up of some vertices and some edges. And the study of that, in short, I can say it is a graph theory. So there is a proper definition of a graph is there that we will discuss in detail. But the basic concepts of the graph theory, some algorithm of connectedness, that means if you have a graph is given, then algorithm, what are the algorithm for connectedness, what are the algorithm to find out the shortest paths, minimum spanning tree, all these things we are going to study in this graph theory. Those who have done the course of BSc Mathematics, they might be studied this paper, whole paper, as one paper of their graduation. And there are various applications of graph theory is there. For example, Facebook is one of the example of a graph. If you consider every profile in a Facebook is as a vertices, and that profile having some of in the friend list, that is another vertices. So if the two profiles are, if I can say, they are connected via vertices, if they are friend, so in that manner, this is the first vertices, which is a profile of yours, and this is another vertices, which is profile your friend. If these two profiles are having a friend to each other, then we'll connect via an edge. There is another vertices is there. If this person is not friend of yours, then there will be no edge between these two. And in that manner, the whole graph is constructed. And the study of this, it goes under the graph theory. For example, that I can give you another example of a web pages. So if the one web page is linked to another web page, then there is a connection between one web page to another web page, and so on. So in that manner, you can construct the whole graph of a web pages. And then it is interesting to find out what is the opening some web pages through one another web page. So if I have on this web page, how many clicks I need to open some another web page which is here. Maybe we don't know whether it is connected. That means if this web page having the link of this web page, or via some other web page, this web page will be open. So that is the problem of finding the shortest path into the graph. So there are various and interesting properties of this graph theory, and there are various applications of graph theories available in the literature. So we'll study the first topic, it is in graph theory. Second topic is a high dimensional spaces. Now what do you mean by high dimensional spaces? You probably, those who have studied their BSc mathematics or statistics or maybe computer science, they have learned about the dimension of a system. Even though in the linear algebra you have learned about what do you mean by dimensional. So if I talk R2, that means it is a two-dimensional space. So there we can talk about the circle, square, triangle, and so on. Then the next question you can ask, what will be the area of the circle? Then you can go for the R3, that is a three-dimensional space, that is in a space we have. So in there we can talk about the very well-known objects like sphere, ellipsoid, cuboid, and so on. But if I give you a space which having 21 dimensions, what will be the sphere in this dimension? What is the area, or sorry, what is the volume of that sphere? If the volume is there, how the volume is behave of such high dimensional space? So all sort of things we are going to study into this high dimension space. The next one, the third topic, is a random graph. A random graph is again a portion of the graph theory, but a random graph itself is a big subject. As I given you an example of a Facebook is a graph, at the same times a Facebook is an example of a random graph, because if I pick up any two profile into the Facebook, then it is a random process that two profile is connected via an edge. And there are various other problems, in real life problems you can discuss on a random graph. Now when you study a random graph, that means it is a graph which is generating a random way. It is randomly generated. So in that, if the graph is randomly generated, then there are problems of whether the given graph is connected. For example, a Facebook, if we can treat as Facebook as one of the example, then I can say that Facebook is not connected. That means every profile in the Facebook, if I pick any two profile in the Facebook, if I can find out a path between that two via some another profiles, then it is called a connected graph. But the Facebook is not connected because we cannot have, or maybe possible that I cannot have a path between my profile to another person in the world. So such problems we are discussing, that under which situation the graph will be connected, under which situation the graph will have a giant component, under which situation the graph has a cycle, under which situation a graph has a shortest path, and how much shortest path is possible to reach to one person to another person in the random graph. So that means if I pick a two profile in the graph, how many shortest number of persons required to connect to reach to one person to another person? Any two profile I can pick. And then what will be the shortest number of profile I have to visit to reach to that person? For example, if I want to see the profile of Narendra Modi, I don't know personally, in my Facebook list, the Mr. Narendra Modi is not there. Then the question is, how much profile I need to search to reach the Narendra Modi? And this problem is very well-known problem, and current scenario, current situations tells you that you will need to reach only 4 profile to reach a Narendra Modi from my profile. So you have to contact only 4 person to reach to Narendra Modi. And as this graph is denser, that means yes, the more vertices are added, maybe in the future this number will maybe reduce. So this is a kind of a random graph is there, and this kind of study we have to do it in the random graph. The next one is a singular value decomposition, that is known as SVD. In the linear algebra, probably you have studied regarding the decomposition of any matrix. If you have given a matrix A, then this matrix is decomposed into some another matrix, for example, lower triangular matrix and upper triangular matrix. Any matrix A is decomposed as orthogonal matrix, diagonal matrix, and orthogonal matrix. This is known as a diagonalization process. And in the singular value decomposition, and is applicable for any matrix A, whether it is a square matrix or it is a rectangular matrix. For any matrix I can give you, you can able to find out its decomposition. Why this decomposition is needed? To know how the matrices behave, how much rotation is there, how much stretching is there. And the application of the singular value decomposition is very large in the area of image processing, principal component analysis, and so on. So in the image processing is very much application is there to reduce its size. For example, if a satellite capture one picture and satellites want to send that picture to the earth via some medium, but then the satellites need to think how I can send this picture so that the data, whatever the information that I want to send to the earth, it has to be rich, fast, as well as sufficient. So whatever the picture, if the satellites have taken, if it will send by some medium, then the size of that picture should be reduced, as well as the information what he need to or satellites need to send, it is also restored. The information will not be destroyed. So what is the technique the satellite is used to do this? It is SVD. Okay. So actually it is doing the sum of the work of a dimensional reduction things, and how it will be done, that we will discuss in this singular value decomposition portion. And the next topic is a random walk. Personally believe that random walk does not deal with any of the big data problems, but random walk is dealing to predicting some situations. For example, in a stock market, a share of some company is tomorrow it will be high or it will be low. To do the prediction of that, one can use the random walk, and it is very useful for economics. Those who are doing the economic background, the random walk is very much useful to predicting anything, to predicting that tomorrow will be a rain or not. Maybe one of the ways to predict that, which existence in random walk. The next topic is algorithm for massive data. So in the algorithm for massive data, that means we are studying here the frequency moments for data streams. That means if one stream is there, then another stream is coming. What is the frequency moment for that? And we will discuss some of the matrix algorithm into this massive data. For example, why this matrix algorithm, especially the multiplication algorithm, is useful, because you are dealing with some big matrices A and B. A is a matrix, B is another matrix, and when you do the product of these two, then if it is of order m cross n, if it is order n cross L, B is of order n cross L, then actually you required with usual manner order m and L time to compute AB. If m is big, n is big, and L is also big, like 10 lakhs rows and column in A and rows and column in B, then this order is very, very, very big, and your computer to compute the product of A and B is not sufficient. Then what to do? What are the algorithm for to reducing our work in such manner? So there are different various techniques to deal with this product of AB, and that algorithms we will discuss in this massive data problems. So that is for this course of fundamental data science we are going to discuss. If you have any questions regarding these topics, you can ask.